Welcome to Brain Vision.
This is chapter 27, problem number 80. We have a cyclotron and an alpha particle. In part A, we're trying to, based on the data that is given to us, we're trying to figure out what charge over mass ratio is. So in order to establish that, we need to do a little bit of work. QBB is going to be equal to mv squared over r. So canceling out v's from each side, then we're going to have the speed to be qbr over mass. Then also the velocity, the speed is for circular motion, it's 2 pi r over period. Period is actually proportional to 1 over f, so then we have 2 pi r f. So taking these two equations here, qbr over m equals 2 pi r f. R's are going to cancel, so frequency would be equal to qb over 2 pi m. Now, this is going to be an important equation. We're going to need this over and over. In part A, we're asked to calculate q over m. Then let's isolate q over m out of this equation. It's going to be 2 pi f over v. 2 pi f over v, so the frequency over magnetic field, this is basically your slope that is given to you. For me, I calculated the slope based on one data point. If you want to be more precise with your answer, you should plot it on Excel and get the slope information regarding the slope out of there. But I'm going to use my slope to be, I'm going to take the last point on the graph. That is something like 35 times 10 to the power 5 over 0.4 almost. So it gives me 7.75 times 10 to the power 6. So I'm going to use that slope. Again, going back to the problem, we are actually asked to calculate the mass of an alpha particle. Given that Q is 2e, then mass is basically going to be, let's rewrite it, Q over m is 2 pi slope. Then m from here is going to be q over 2 pi slope. Then q is 2e, 2 pi slope. Then 2's are going to cancel. What we have is 1.6 times 10 to the power negative 19 divided by 3.4. And this value here, 7.75 times 10 to the power 6. If we did that, then the mass would come out to be 6.6 times 10 to the power negative 27 kilograms. This is close enough, right? Considering that the in an alpha particle we have 4 protons, almost 4 times the mass of a proton here. Now, in part B, we're asked to calculate the frequency of a proton. So let's remember QB times m 2 pi mp. This is again the equation that we derived. I'm just writing it for a proton. So the Q for a proton is 1.6 times 10 to the power negative 19. The magnetic field is 0.3 to 3.14. Mass will be 1.67 times 10 to the negative 27. So the frequency of a proton would be 4.6 times 10 to the power 6 hertz. If we did the same for an electron, QeV over 2 pi me, only difference is that now we have the mass of an electron, 1.6 times 10 to the negative 19.3 divided by 2 times 3.14 times 9.11 times 10 to the power negative 31. This is going to give us 8.4 times 10 to the power 9 hertz. Now, let's do the same for the alpha particle. For the alpha particle, we would have Q alpha be over 2 pi m alpha, right? So, as you know, in an alpha particle, we have QA to be 2e and m to be ma, let's call it 4 times the protons. And then if we do the conversion between the mass of a proton and the mass of an electron, then what we have is 1,836 times the mass of the electron, right? So let's pick one and plug in the values for the frequency of alpha particle. It will be 2eV over 2 pi 4 times the mass of the proton. These are going to cancel out. 1.6 times 10 to the negative 19 times 0.3 divided by 3.14 times 4 times 1.67 times 10 to the negative 27. We're going to get 2.3 times 10 to the 6 hertz for the frequency of an alpha particle. Now, then comparing the results, you can tell that the frequency of an alpha particle is basically half of the frequency of the proton, right? Because we had found the protons to be 4.6 and now alpha particles being 2.3, exactly half. And in relation to the frequency of the electron then, Fa, again, 2eV over 2 pi, right? 4 times 1836 times NE now. That we just did the conversion that we established here. Now going back, as you know, EV 2 pi ME was already the frequency of the electron. Now then what we have, these are going to cancel. We're going to have 2 here. Then 2 times 1836 Fe over 2 times 1836 is going to give us the relationship between the two frequencies, 3672, right? Now in part C, we are asked to calculate the speed. So again, from the equation that we established on the first page, QBR over M. For Q, we have 2 times the electron charge, well, proton's charge is positive, so the B field is 0.3. The radius is given to us as 0.12 divided by 6.65 times 10 to the negative 27, right? The mass for the alpha particle. From here, we can get the speed to be 1.73 times 10 to the 6 meters per second, and then plug in this information in the kinetic energy equation. We find, well, the mass is 6.65 times 10 to the negative 27, 1.73 times 10 to the 6 squared. The answer would be something like 1 times 10 to the negative 14 joules.